So we want to find the, let's do black here, find the area of the region enclosed by the graph or by the curves y equals 1 over x, so y equals x, and y equals 1/4 x. Right, and we want to do this two different ways. The first is where x is the variable of integration. Right, and so we know that we have an integral with respect to x, right, when we're taking these rectangles of height yt minus yb, right? And so we'll have this top and bottom function, right? Curve, I mean. So let's first graph our region here. So we have some issues with our Wi-Fi here, but we have y equals 1 over x. We'll do that in red. Looks like this. Y equals 1 over x. And actually, really, there's two parts to this graph. Looks like it has this kind of positive and negative portion, right? And then we have this curve y equals x, which of course is just our vertical, or our, not vertical, diagonal line, right? Y equals x. And then the line y equals 1/4 x. We'll do that in blue here, right? That's just another line, and it has a lower positive slope. Looks like this, right? So what isn't really mentioned in the question itself is that there are actually two kind of parts to this region here, and there's the part in quadrant 1, and then there's this part in quadrant 3, right? So let's just find the area of the region in quadrant 1. Right, so we're going to just kind of get rid of this portion of the curve here. So we're just going to look at this region that we have over here, right? So now we have this region, right, that we want to find the area of, and we want to do this by, forming an integral with respect to x, right? That corresponds to these kind of like vertical rectangles, right, of width delta x and height yt minus yb. Right, and what you might notice here is that the what's on top and what's on bottom changes, similar to one of the examples that we already covered. I believe that was the second example. And so we have to kind of figure out where this kind of happens, right? Is along, it's like right here, right? On the left side of this vertical line I have drawn, the top curve is the green one and the bottom curve is the blue one. On the right side, the top curve is the red one and the bottom curve is the blue one. So really it's just kind of the top curve that changes. These two regions. Call this one R1, and then we'll call this other one R2. Right, and so we have that the whole region here is just, the union of R1 and R2, so the area will just be the sum of the areas of these two regions, right? And we need to figure out our limits of integration, so we really need to figure out where these curves intersect. So first we know we have an intersection here at 0, 0, but what is this point here where the green and red intersect? Right, so we have that happens when y equals x is equal to 1 over x, right, which happens when x squared is equal to 1, or when x is equal to plus or minus 1, right? Of course, we know that the minus 1 is corresponding to this point here, but again, we aren't concerned with that, so really just x equals 1, right? And so we'll go, let's see, go kind of down a little bit. Sorry, we're lagging a little bit. And we'll first find the area of R1, right? So R1 is this portion of the region from x equals 0, right, to x equals 1. This is 0 here. So we have that A1. Oh, and what's our top and bottom function here? Well, yt is equal to the green one is just x, and yb is equal to the blue one, which is 1/4 x. So we have that a1 is equal to this integral from 0 to 1 of x minus 1/4 x dx. And that is equal to the integral, we can simplify this a little bit, right? That's equal to the integral from 0 to 1 of 3/4 x. So this is 3/4 x squared over 2 from 0 to 1, right? And that is 3/8. 1 squared minus 0 squared, which is just 3/8, right? So that's A1. Now we want to find A2. So we have to figure out our other intersection point here, right? So this intersection point, right? So that is where the blue and the red meet, and so that is where 1/4 x is equal to 1 over x, right? Multiplying both sides by x, we get x squared over 4 equals 1, right? Kind of move that over a little bit. So that's when x is equal to plus or minus 2. Again, the negative 2 is corresponding to this point in the third quadrant, right? So we discard that and we just take x equals 2, right? So now R2 is this region from x equals 1 to x equals 2. And our top function, yt, is equal to the red one, right? 1 over x, and then yb is equal to the bottom one, which is the blue, so that's 1/4 x, right? And so a2 is equal to this integral from 1 to 2, 1 over x minus x over 4 dx, right? What's the integral of 1 over x? Well, we should hopefully know that already, but yeah, it's just the natural log, right? This is that one exception to the power rule, right, where the power on x is -1, and so in that case, our integral is ln of absolute value of x. So this is ln absolute value of x minus x squared over 4 times 2, right? And that's from 1 to 2, excuse me. So this is ln of x minus x squared over 8, 1 to 2, which is ln of 2. We can drop the absolute value sign here because 2 is obviously positive, right? Minus 2 squared over 8 minus the quantity ln of 1 minus 1 squared over 8. And we have ln 2 minus 4 over 8. Remember that ln of 1 is just equal to 0. So this is, we're subtracting negative 1/8. So we're adding 1/8. And we get ln of 2 minus 4/8 plus 1/8. So minus 3/8. And so we get that our, right, so that's our area of the second region, right? So we have, right, so this is our area of the second region, this is our area of the first region, right? So putting that together, we have our total area here, zoom back in, is equal to this 3/8 plus ln of 2 minus 3/8, which is just ln of 2, which is of course a positive numbers, just a sanity check, right? So that's what we get for our area. And remember, this was just our, right, so this is our area. So this is just our, the first part of this problem, because we also want to see this done with respect to y, right? So where y is the variable of integration. So let's just go to a separate kind of area here. And let's do this problem again now with y as the variable of integration. So we have right, we have these same curves and they look the same, right? But now we want to kind of look at everything with respect to y, right? So we have y equals 1 over x is the same as x equals 1 over y, right? Y equals x, well, we're just kind of writing this in a different order, right? X is equal to y. And then y equals 1/4 x is the same as x is equal to 4y, right? So try to do this with the same colors scheme. So this is our x is equal to 1 over y. And then our x is equal to y is green here, and then blue we used for this y equals 1/4 x, which is x equals 4y, right? It looks like this, and we're not gonna mention that portion in the third quadrant because we know that we don't care about that part. Although if we did, then we could just by symmetry double what we get for the first quadrant. So we have this region here, which, right, we have this region here. And we want to find the area. So we want to do this with respect to y, right? And so we know that that corresponds to having this view where we have, I don't want to use that color, this left and right curve, right? We have left and right curves instead of top and bottom curves. Right, so we have something like this, right? And that corresponds to taking these kind of like horizontal rectangles, right? And they have this, you know, like this height, which is really like a horizontal length, xr minus xl, and this width delta y, right? But what you notice here is that, again, you know, our right and left curves are different for different portions of this region, right? So let's kind of get rid of that. And kind of where does that left and right curve change, right? But if we draw this horizontal line corresponding to this y value where the blue and red meet, then we see that the right curve above this horizontal line is red and the left curve is green, and then below the horizontal line we see that the right curve is the blue one and the left curve is the green one, right? So that's kind of where we want to segment this region. Okay, so we have this kind of region 1, and then this region 2, right? We want to find our intersection points, and we know our kind of first intersection point here is just the origin, and then we have these 2 other intersection points right here and here. So we did actually already find these with respect to x, but so we could just use those and just figure out the y values, but let's just do it with respect to y here. So where the green and red meet is where y is equal to 1 over y, which is, when y squared is equal to 1, y is equal to plus or minus 1, and for quadrant 1, that's just y equals 1, right? And then the other one is where the blue and red meet, and that's where we kind of segment the region into 2 parts, and that's where 4y is equal to 1 over y, so that's where y squared, right, 4y squared is equal to 1/4, right? So that's where, oops, sorry, not 1/4, right, 4y squared is equal to 1, and so that's where y squared is equal to 1/4, or y is equal to positive or negative 1/2, but again, in quadrant 1, we just have y equals positive 1/2. Right, so we have, this is 1/2 here, and this is 1, right? Okay, so now we know that the region, I'm gonna just kind of shift over here. The region is just, the whole region is the union of these 2 regions. And so the area is just going to be A1 plus A2, where A1 is the area of region 1, A2 is the area of region 2. So we have to find A1 and A2. So now let's do A1 first. So that was corresponding to region 1. So that is region 1 is this region from y equals 1/2 to y equals 1. And there, the right curve is the red, right? The red curve. And the left curve is the green curve. Right, so A1 is just equal to this integral from 1/2 to 1 of 1 over y minus y dy. And that is equal to ln of absolute value of y minus y squared over 2 from 1/2 to 1. So this is ln of 1 minus 1 squared over 2, which is the same as 1 over 2, minus ln of 1/2 minus 1/2 squared over 2, right? And this is, we know ln of 1 is 0. So this is negative 1/2 minus ln of 1/2. And then here, right, we're distributing the negatives, so that's going to be plus 1/2 squared is 1/4, right, over 2. So that's going to be 1/8. Right, so this is negative ln of 1/2 minus 1/2 plus 1/8, right? We're going to do a little bit here just to clean this up. So this this negative ln of 1/2, right, is negative 1 times ln of 1/2, right? And remember our little law here. Maybe I'll put it somewhere actually. But our little natural or just general log laws tell us that if we have, you know, ln of something to a power, that's the same as this constant c being brought down as a constant multiple, right? So it's this law here, which means that ln of negative ln of 1/2 is the same as, right, so we're kind of starting on this like right side where we have a constant multiple of negative 1, is the same as ln of 1/2 raised to the negative 1 power, which is ln of 2. Right, so this is ln, and this is just a little aside here. So, so this is ln of 2 minus 1/2 plus 1/8. And what is 1/2 plus 1/8? We can get a common denominator of 8. So this is, by multiplying by 4 over 4, we get that this is ln of 2 minus 3/8. Right? So this is actually the same, I believe, as the area of one of those regions that we did in the first part. Okay, so now let's do, sorry, this is kind of shifting all over the place here. It's I think it's the Wi-Fi. Okay, so now we want to find the area A2, right? The area of region 2. So let's use this little color scheme here. All right, so now we have that R2 is this region, sorry, R2 is this region from y equals 0 to y equals 1/2, right? Again, sorry for the lag. That's just my internet connection's not too great today. So, yeah, so this is 0 to 1/2, right? And then we want to say what is our xr and what is our xl, right? What's the right function, what's the left function here? Well, so going back here, right, we're looking at this kind of bottom region, and we have that the right function is the blue one, right? So xr is equal to 4y. And the left function is this x equals y, so it's our xl is equal to y, right? Okay, so now we have that a2 is equal to the integral from 0 to 1/2 of 4y minus y dy. And so this we can just write as the integral of 3y, right? And that's just 3y squared over 2 from 0 to 1/2. That one was pretty easy, right? And evaluating, we have 3 times 1/2 quantity squared over 2 minus, okay, that didn't show up at all. So, right, so 3 times 1/2 quantity squared over 2 minus 3 times 0 squared over 2. Of course, this which is going to be 0, is equal to 3 times 1/4 over 2. Right, that's times. And so that is just 3 over 8. That's our A2. Right, so that's our A2. You know, our A1 over here was this ln of 2 minus 3/8. Oops. And so our total area, right, is the A1 plus A2, right? Go back here. And that's just going to be this ln of 2 minus 3/8 plus 3/8, which is just ln of 2. Okay, and no surprise there that these are the same, right? We get the same answer whether we integrate with respect to x or integrate with respect to y, right? ln of 2.